Some experiments with glow sticks today. I got a couple over there on the right. All right, let's see. Let me get the camera set here. Hope everyone's doing okay this afternoon. Let me get this set here. There we go. Yeah, we're gonna get that looking just right. That looks a little better. All right. Well, let's get busy. Let's get going here. All right. What am I doing? Well, we're gonna try a bunch of stuff today. I'm gonna take this glow stick here. Let's get this glow stick going. Bensky, welcome aboard. Hello there, Thato. Look at that. Isn't that kind of cool? I don't know if you noticed, but before I got this glow stick going, you could see that it had like orange colored dyes in it. But when it's glowing, it appears white. Isn't that kind of interesting? The color of a glow stick, it comes from different dyes that are contained in the light stick. And I'm going to go ahead, let's see if we can't get some of this glow stick material into this flask here. The way I'm going to do that is I'm going to take a PVC cutter right here, and we're going to, can I throw it? There you go. All right, let's go ahead and cut the top of this off. Here we go. I'm going to do this carefully because I don't want the fluid to spray all over the place. There we go. That's a pretty good cut. And we'll dump the material into the beaker. Isn't that beautiful? Just pretty. Oh, yeah. So we got some glowing glow stick fluid there. Lots of fun. Let's do this for a couple of them, then we'll do some experiments with it, shall we? I think that's going to be a good time. I actually got to find a place to stick my cut open light sticks, glow sticks. Excuse me a second. I got an empty bottle around here somewhere, down here in my lab. Should have had this ready. I apologize. This will work. This one will work right here. So this will be my container back here where I'll put the empty glow stick material. Yeah. So we're going to learn a little bit about the chemistry of glow sticks. If you're interested in that, drop me a line. We can talk about that, all right? Can I tell you how it glows? Well, there's the question. Let's go ahead and talk about that. I don't know there, Mike. Hello there, Thato. Okay, so here's how a glow stick works. It's a little hard to see here, so let me keep the light on. So there's, in any glow stick, there's this molecule. They can be different types, but there's this one. It looks kind of complicated, but it's called bis for 2, trichlorophenyl oxalate. So long there, Bensky. So it's a molecule that looks like this. The trichloro comes from the 3 chlorines on this thing that looks like an eyeball. That's what we call a phenyl ring. And there's 2 of them. So there's 2 trichlorophenyls. And then in the middle, we call this an oxalate. And what happens is you react that with some hydrogen peroxide. That's what happens when you snap the light stick. Those 2 components end up mixing and reacting. And what they do is you get what happens is it snips right here. It snips right here. And you get 2 trichlorophenols. We're not really interested in these after that. But what you also get is this thing in the middle kind of snaps together into what I'm going to call a dimer. That's 2 carbon dioxides hooked together. It's got a funny name, dioxetane dione, but you can think of it as 2 carbon dioxide molecules stuck together. Not quite there, Dual. Not quite. We're not dealing with any of that tonight. Anyway, this is a very high-energy molecule, and this high-energy double carbon dioxide, it reacts with dye molecules that are present in the light stick. And you can see this light stick here. It's got like peach-colored dyes. It's a mixture of them. And when that happens, sure enough, the double carbon dioxide molecule gets split into 2 molecules of carbon dioxide, but the dye gains some energy in this process. And we signify that by putting this little asterisk here. And what's cool is the dye then gives off that energy as light. And different dyes give off different color. Hey, thanks there, the IGMER. Okay, I'm not sure how to do that right now. I'm low budget here. Okay, let's go ahead and we'll get this light stick going. So when I crack it like this, the dye and the phenyloxylate and the hydrogen peroxide, they all mix. And then we get the glow from the chemical reaction. Now what we're going to do is we're going to start collecting some of this stuff. You can already see I got a little bit in the beaker back here. And we're going to do some experiments with it. I just want to get a little bit extra before I get started. There we go. So the way I get the material is I take a PVC pipe cutter, get it right up here close to the top, and very gently I'm going to squeeze it because I don't want glowing light stick fluid to go all over the place. All right, I'm going to take the plastic, pop it in my waste container here in the back. Oh, I forgot to take the lid off. There we go. Let's leave the lid off. All right, let's dump some of it in and watch what happens, huh? I don't have any nitric or sulfuric with me, so let's pour it in there. You can see it going down the side, nice and pretty. Some of the glass vial that the peroxide in might fall out. I'm going to try to avoid that. But yeah, we've collected a little bit of glowing light stick fluid that I can do some experiments with now. And basically what I'm going to do is I'm going to show you that different dyes give different colors. Hey, thank you there, Maria. Okay, let me get another cup so I can start showing some stuff to you here. Let's use, I'm going to think this size I think will work. These cups should work. I got to experiment. I haven't done it in a while. I want to see if I can get it to work tonight. We'll see. We will see. Okay, so I've got a little cup here, and what I'm going to do is I'm going to take some of this glowing light stick fluid. We're going to pour it into this container here, and we'll leave this back here as our control. All right, and then to the one up here in the front, I'm going to add some food dye. Try and light it on fire. What an interesting idea. I'm pretty sure it would burn. What an interesting idea there, Oreo. I might have to try that. Not on the live for sure, but we might try it sometime. Anyway, let me go ahead and add a little drop of food dye to this. And remember, the different colors of the different dyes in the light stick give you their different colors. So we're going to add just a little drop here. All right, and let's swirl it around and see what happens. So the dye I added is just simple red food dye. Give it a swirl. See if it goes in. It looks like it's kind of, there we go. It's suspended in the fluid. It's not dissolving in as well as I'd like. Let me try another drop here. There we go. Another drop. There we go. And you can see. So what I've done is I've added a different dye. The dye is fluorescing. I can tell it's fluorescing because you can see the color has shifted, right? That this is now not just a white glow. It now kind of looks like a pinkish red glow. And that's because indeed the dye that I added, the particular dye that I added, it's red dye number 40. It does tend to give off a red-orange fluorescence. In this case, we're seeing it kind of like a pink color. Let's try another one. Let's see if I can get a different color here. Let's go with, I think we're going to try, let's try turmeric. So turmeric contains so I'm going to use these natural food coloring dyes. A lot of natural dyes are fluorescent, and those are the kinds of dyes that you want in these experiments. Hello there. Hello, my name. Let's add some turmeric to the next one, okay? There we go. I'm going to add a couple drops here of the yellow turmeric dye. All right. Natural food dye. And we're going to go ahead and Add in our glow stick fluid and see what happens, baby. Come on now, what's going to go on? Swirl that around. See if we can get a color shift, a glowing color shift. It's taking a bit. There we go. I might need a little bit more fluid, eh? I'm having a little difficulty getting everything. There we go. You can see now we definitely have like a yellowish green fluorescence. And again, the color shifted because just like different markers give you different colors, different colored dyes in fluorescent light sticks are going to give you different colors of glow. Make it a fake firefly. You know what? I think, Spiral, it is, and hello, I think it does kind of already look like the color of a fake firefly, which is kind of fun. All right, here's the new experiment I'm going to try. I haven't done this before. Let's get some more glowing fluid for a bit here. I'm going to open up a new glow stick. I love it, Spiral account. Spiral says, I mean, you didn't explicitly say this, but it's kind of like it's a fake firefly, which I think maybe, yeah. Little yellow glow there. Looks kind of nice. I can pour a little bit more in here. See if we can get that glow going. Yeah, look at how when I add fresh material, everything glows just a little more nicely. Very pretty. Very beautiful. Okay, let's get some fresh glow stick mixture. I got to get my trusty PVC cutter. We're going to open this up. So the chemical reaction that powers a light stick is actually the reaction between a molecule, a complicated molecule called phenyl oxalate, and hydrogen peroxide. Hydrogen peroxide is not that complicated. It's just like, it's a lot like water. I don't want to say it's a lot like water, but it's similar to water, but it's got an extra oxygen atom. All right, let's go ahead and take this material, pour it into our batch back here. Hey, Jack, what's going on? My son just came down to say...
We're about to head out.
All right, my kid's saying goodbye to me. Say hi to everybody.
What's up? How's it going?
And his girlfriend is here too.
I'm saying hi. Hello.
Hello, hello. We're doing goofy experiments with glow sticks.
Oh,
this
what
is
are you
cool.
doing?
Well, I'll show you. I'm going to try to get chlorophyll to fluoresce. You know what chlorophyll's in?
Yeah.
I'm giving you a science lesson here, baby. Chlorophyll is in, where is it? In broccoli. I got some broccoli here. So we're going to try to extract some chlorophyll from broccoli. It does glow. It definitely glows, and you get different colored light sticks from different dyes. I'm going to actually try to extract the dye chlorophyll from this broccoli, and then we're going to see if we can't get the chlorophyll to glow. Remember, chlorophyll is what gives plants their green color. It's a little icy there because I just got it out of the fridge. Okay, to extract it, we're going to use this. I'm going to put I usually use spinach. I've never tried broccoli before, so this might be a huge dud. So long. Oh, you're hanging out? I don't know if they're hanging out or staying. The best use for broccoli. Come on, man. You tell me they're hot gas. I totally agree. Give me a broccoli emoji in the chat if you like eating broccoli. There we go. Sure. It doesn't bother me.
Okay.
Andrew, can you send me white phosphorus if you'd like? All right. So there goes the broccoli. And now what I'm going to do to extract the chlorophyll, I agree. At least I don't have to eat it either. What I'm going to do to extract it is I'm going to add some acetone. Acetone's a really good solvent. It's going to be a fairly good way to get the chlorophyll out of the broccoli. So in goes, there's some acetone. Let's swirl, and hopefully we're going to see the mixture turn like a green color. So I don't know, is the fluid turning green? Yes, it is used in nail polish remover. Yeah, I'm liking some broccoli with ranch too there, Spiral. We got at least one person who likes broccoli in the chat. It's kind of cold because when you mix ice and acetone, it gets really cold. I don't know if this is going to work. I think I'm going to need to mash it up a little bit. We got to get that water, I say. We got to get the we got to get the acetone a really deep green color. I'm going to try to mash it up a bit. What do I have here? This will work. Oh, rats. Okay. I apologize if this is a dud. Okay. Let's mash it up. Thank you there, Ellis. I appreciate that. Thanks for letting me know. I'm going to try to... I know I'm using a pencil as my stir bar, which isn't the best thing in the world, but it's all I got down here in my basement where I'm doing the experiments. Yeah, that's not going to be a dark green enough color. This might be an issue, folks. This might be a dud experiment. That's what happens when I try experiments live and I haven't done them prior with a test. Yeah, it's really tough to get that stuff out, but you can see it's got like a slight green color to it, yeah? That might be good enough. Okay. Let's give this a shot. I'm now going to filter the mixture, collect the material. Let me get my filter out and see what color it is. Probably would be better if this is warmer. That's probably my issue. I'm trying to warm it with my hand here a little bit. That's going to help if it's warm. I don't know if that's green enough or not. I want as much dye as I can get. I don't think I have enough. Try spinach next time, Tommy T. Okay, let's give it a shot. Enough waiting. Let me get a receptacle to catch everything in. That's a nice looking vessel. We'll try this. I got my funnel. We'll back it off so you can see what I'm doing here. Back up the camera a little bit. There we go. So I've got my chlorophyll from the broccoli into this flask. And we're going to just put it in here, see what happens. Here we go. See what kind of stuff comes through. See if it's going to be green enough. That's what I'm looking for. I want it to be nice and green. It's like a yellow-green, isn't it? Interesting, man. I don't know if that's going to fluoresce or not, but we're going to find out. We are going to find out. What's interesting is it kind of has like a... It's not a solution. I'm used to seeing a solution when I do this with spinach. So you can totally see through the mixture immediately. Broccoli and nail polish remover. How you doing there, Adiaman? I'm doing fine. Well, we're going to give it a shot. I don't think it's going to work, but we're going to try it anyways. Well, what am I trying? Just for those of you who might be just coming on board, what I've done is I've extracted, I took some nail polish remover and mixed it with some broccoli, and I collected this stuff from the mixture. And I'm going to pour some glow stick mixture in there and see if it changes the color of the glow. That's what we're doing. Because different dyes glow different colors. And so I'm wondering if the broccoli dyes, specifically chlorophyll is what I'm interested in, but I'm interested in if the broccoli dyes can change the color of a white glow stick. That's what we're going to go for. All right, so let's put this back here. I should have warmed this. That would have helped. But anyway, just to give you an idea of where we're at. So I took this glowing white light stick mixture and I added red food dye to it. And sure enough, we've got like this glowing red material because different dyes are going to give you different colors. I also added some turmeric. This one looks like it's no longer glowing, but the turmeric in here, let's add a bit more. I think the issue with the turmeric is it's a little bit acidic, and acid tends to quench the glow stick reaction. But you can see there, if I add a bit of the glow stick mixture, instead of it glowing white, when it's added to the turmeric, it's going to glow a yellow color. Let me add base. That may help, because base catalyzes the reaction. That may take care of the issue where, let's add a little bit of base to these. We'll see if we can't get this kicking up here. So I'm going to add a little bit of base. There you go. Look at that. Come on, baby. Come on, look at that. So you can totally see when I add the base, that's going to catalyze the reaction. Sure enough, we get a gorgeous green glow when I do that. And that just happened because, again, acid, which I think the dye contains some acid. Acid tends to quench the light stick reaction, where base is going to catalyze it. Here, I'll add a little bit of base to this. It should catalyze the reaction, pick it up. We're going to get a little bit more glow here. Look at that. Come on, man. Look at that. It's glowing orange, man. That is so gorgeous. Oh, my gosh. There's like these glowing look at this. There's these interesting glowing patterns. That is gorgeous. Isn't that cool? Got the same kind of thing going on here. Yeah, so, a base like sodium hydroxide is going to catalyze the glowing light stick reaction. Add chocolate milk. I don't know, man. All right, we're going to try the same thing here now. We're going to do it with this stuff, all right? So I'm going to add this stuff that I extracted. Thank you there, the big. I extracted this from broccoli, and we're going to add it to this glowing white light stick mixture. Let's see what we get, baby. Come on, let's see what we get. I think I'm going to add some of the phycocyanin that I have, too. Anyway, let's go ahead and add our glowing white light stick mixture here. I don't think this is very drinkable, although my dog did eat a glow stick once, and she didn't like it, that's for sure, but she was no worse for the wear. Okay, so let's add a little bit of this stuff from broccoli. In it goes. There's no way this is going to work. No way this is working. In goes the broccoli material. And I'm going to add a little bit of base to see if we can't kickstart the reaction a little better. Let's just try it. Or is that acid that I'm adding? Hold on. Nope, that's sodium hydroxide, so we're good. Yeah, I think that experiment was a dud. I should have used spinach. Doggone it. I apologize, everybody. That is a... Whoa, no way. No way. That's totally working. Holy crap, look at that. You can totally see the red glow. I thought it was going to be a dud, but you are totally seeing glow from the chlorophyll. That's freaking cool. Let's add a little bit more. Come on, man. That is awesome. A little bit more of the glow fluid, or excuse me, the dye. So that's the fluid from the broccoli, which contains some chlorophyll. Chlorophyll indeed fluoresces red. There's the glow stick mixture. I'm going to swirl it a little bit. And to get that red glow, there it is. I see it, but I'm going to add a bunch of base to really kick it off here. The base really helps it pick up the glow. Look at that, everybody. It worked. And the reason why it's a faint glow is because I think y'all noticed that the green that I extracted, it wasn't very concentrated in chlorophyll. Thank you there, the big. It worked, everybody. I'm so excited. That is actually, I think in another experiment, I'll make sure to use spinach, because spinach will definitely work. When I do this experiment with spinach, I get a beautiful green solution that, and the red fluorescence shows up very nicely. But yeah, we got it. It's just a slight pink glow from the chlorophyll that I extracted from broccoli. Leaves, tea leaves would be great hot gas. Belgian turtle sees broccoli. Oh, I'm so happy. I mean, I know it's not that, it's not like glowing like this or anything. This is just the red food dye. Look at that. That red food dye just gives you this fiery red-orange fluorescence. It's just so beautiful. And what's nice is the food dye doesn't completely dissolve into the glowing light stick mixture, and so you get these pockets of undissolved material that just give you the very interesting effect. Okay, we're going to try something else. We're going to try another one. So here we go. I am too hot gas. So what you would want to do, hot gas, and this would actually help me out, everybody, is what you would do is you would look up dyes that fluoresce. Dyes that fluoresce that you can easily get your hands on. Oh, yeah, we're doing some glowing stuff there, Lord. So we're going to try this. So this is blue food dye. It's natural food dye. Food coloring with no artificial dyes. And this is the blue version of it. And if you look at the blue version of it, it says here that it contains spirulina extract. Now, spirulina extract contains a molecule called phycocyanin that fluoresces red, and I can totally see it. I don't know if you noticed, but this doesn't really look blue when the light shines on it. It actually has like a little red or violet tint to it. That's because, thank you there, the big. I mean, big, I can do the other one. I can totally do the other one, but we're going to stick with this for now. Yeah, you can totally see this blue dye is fluorescing red. And it's just, the fluorescence is coming from the fact that the room lights, the lights from the room, hit this. They excite the molecules in here, and they cause the molecules in here to get off red light. No, administrator, this isn't the usual live. I've started to do some experiments with glowing light stick mixture. So here, we can see it here. So you can see here in the back, I've got some glowing fluid from a white light stick. And we're going to see if we can get this blue food dye that contains spirulina, which contains the molecule phycocyanin. Phycocyanin fluoresces a red color. And the different colors in glowing light sticks come from different dyes. And we're going to see if we can get the glowing light stick chemical reaction to get the dye in here to glow a red color. No, this isn't dangerous at all. So we're going to go ahead and I need a little bit more fluid. So we're going to take this white light stick. You're like, that's not white. I can see it's like orange. Well, watch this. If I get it activated, while the dyes appear orange when they're not emitting light, they give off white light when they are emitting light. So when the chemical reaction is happening inside the light stick, the dyes contained in the light stick happen to give off a white color. Plastic into meat. I don't turn any plastic into meat. Okay, here we go. I'm going to go ahead and cut the top off of this so I can get a little bit more glowing light stick fluid. Here we go. Oh, Lord, yeah, there's, obviously they have different colored light sticks. And those different colors, again, they just come from different dyes that are contained in the light stick. Just like different markers have different colors because there's different colored marker dyes, different light sticks have different colors because there are different dyes that you put in the light sticks. The difference is in a light stick, the dyes in a light stick are a special type called fluorescent. And a fluorescent dye gives off light under certain conditions. All right? Oh, so it looks like Lord Stormia tasted some glowing light stick fluid. Yeah, hot gas. Yeah, there definitely are animals that can glow. Of course, fireflies can glow. That's one example of what we call bioluminescence. This is what we call chemiluminescence. It's the emission of light as a result of a chemical reaction. So what I'm going to do now is we're going to try to see if we can get this blue food dye to glow. To fluoresce, I should say. And we're going to use the glowing white light stick mixture to do it. All right. Indeed, Lord. Actually, Lord, you can get a glow stick to glow forever because so these are fluorescent dyes, and fluorescent dyes are usually what we say excited or given energy just by light. And so you can take any old light stick that's even spent, used up, you can add, shine it with UV light and it'll glow. All right, so I added the glowing light stick mixture to the blue. I'm not seeing a whole lot here. I was expecting some red fluorescence from the phycocyanin, but I am not seeing any. Well, that's a bummer. Let me add a little bit of, sometimes this works. I'm going to add a little bit of base to try to kick things off a little bit. Get it really glowing here. Give it a swirl. So the base catalyzes the reaction or speeds it up. So you could probably tell when I added the base, it really started glowing a lot more. Beautiful. Here, I can show you in this one. Here, let's do this. I'll do this from the top. I'll show you this one from the top. So I'll add some, I'm going to add some base to this. It's kind of slowed down a little bit, but watch what happens if I start adding a little bit of base here. Add the drops. Give that baby a swirl. Oh, well, maybe it's dead. Maybe it's dead. Yeah, maybe it's no good. Let's pour it in here and see what happens. Huh? Yeah, I think that one's a dud. That's too bad. One thing I do know and remember from chemistry class, if you heat up the solution, it'll glow brighter. Very nice, Lord. That's totally true. That is totally true. Yep, these if you speed up the chemical reaction by heating it, it indeed will glow more brightly. So these are spent. So I'm going to just take these off to the side. Let's do the red one again for people who haven't seen that one. We'll do the red one. All right, here we go. There's our test cup. In goes the glowing fluid. Beautiful. And to this one, I'm going to add, well, I know it's going to work. We'll give it a shot. Yep. All right, let's add a little bit of the red food dye. Red food dye usually glows an orange color, but it's going to take a little bit of base to get this to work. I'm going to just swirl it around first. It doesn't dissolve real well, but I'm going to go ahead and add some base. That should help it dissolve, and it's also going to kick off. You can totally see it. As I add the base, you can see the reaction really start going, and it really shows some beautiful effects. Let's get that orange fluorescence going, baby. We're going to give it a swirl. Here we go. And sure enough, we've got some orange fluorescence by changing the dye that's in the white light stick mixture. I added some red food dye, which happens to fluoresce orange. And indeed, as it dissolves into the surrounding material, the red food dye is now fluorescing a beautiful orange color. There you go. It looks like it's calming down a little bit, so I'm going to add a bit more base. I may have turned it all off. Yep. So that's another thing, though, is as you can see, the reaction's done. So when you add, a catalyst to a reaction, it sure does speed it up. Absolutely, it speeds up. But that means that the reaction's going to peter out quicker, too, right? It just the thing is done. The glowing fluid is what? It is just glow. Here, I'll show you what the glowing fluid is. So let's put the glowing fluid here. I'm going to take, excuse me a second, I got to turn my light on so I can see what I'm doing. I'm going to take one of these glow sticks, which is, do I want that one? No, I don't want that one. I want this one. All right. Check out the color of this light stick. It looks like it's going to be an orange glow, doesn't it? Well, the dyes in the light stick indeed look orange when they're not glowing, but when they are glowing, it turns to a white color. Get that shaken around. We're going to fill up our beaker. All right. Let's fill up our beaker. The way I do that is I get a pair of PVC cutters. Chocolate milk. I don't have any chocolate milk, Spiral. And I highly doubt there's any fluorescent dyes in chocolate milk. There we go. All right, pop that in there. If you were with us earlier, you saw us get a little bit of, believe it or not, we got some pink glow from broccoli. That was kind of fun. That was definitely fun on my end. All right, in it goes. There's our glowing white light stick fluid. I forgot what I was going to do. What the heck was I going to do, everybody? I don't even remember. Somebody remind me of what I was going to do. We're going to try something. Let's get a couple cups here. Cup here. Cup here. So do you know the specific compounds that make them glow? I do. I do know the specific compounds. Let me show you. Okay, so what are the two liquids inside the sticks? Let's talk about these, okay? Let's talk about this. Hello there, Priyanka. So let me show you this. This is going to be a little bit chemistry heavy. All right? But this is the reaction that happens inside of the light stick. What you do is you have this molecule. There's different forms of this molecule, all right? Different forms of it. This one we call, let me say, it's bis, because there's bis like bicycle. So there's two of these eyeball things on the end of this molecule. This is like the powerhouse of the glow stick, okay? All right, so there's two of these eyeball kind of things on the end. And because of that, we say bis for like bicycle. And you'll notice there's 3 chlorines on the eyeball, so to speak. This eyeball thing was really a thing called a phenyl ring. It's a 6-carbon ring, all right? Bulky group, yep, we can call it bulky group. But there's 3, or trichloro, that's the TC. This eyeball thing is a phenyl group. That's where the P comes from, pH phenyl. So it's trichlorophenyl, that's, bis, because there's 2 of them, bis trichlorophenyl, and then this thing here in the middle is our oxalate. And it's this oxalate portion that really powers the glow stick. Now, how do you get it powered? Well, what you do is you mix it with some hydrogen peroxide. Now, this is why any glow stick is going to have that inner container. That inner container contains the TCPO, the trichlorophenyl oxalate. The outer portion contains the hydrogen peroxide. And when you break the light stick, when you break it, you allow the components to mix. Well, where the heck does the glow come from, and why can we get different colors? Well, the glow comes from the fact that there are different dyes in the light stick. Now, here's how this works. When these 2 things react, the hydrogen peroxide and the TCPO, you get 2 phenols. And we're not really interested in this. You can think of this as a waste product. What we are interested in is this thing here. So the oxalate portion, these oxygens kind of wrap around and they make a ring down here. And if you look closely at this, you'll notice, hey, that's like 2 carbon dioxide molecules linked together. You can think of it as a carbon dioxide dimer. And this is the important piece. Because you see, this carbon dioxide dimer, it interacts with the dye. So these 2 things slam together. And when that happens, there's a chemical reaction that happens to this dimer, and you guessed it, it splits into 2 molecules of carbon dioxide. So that's kind of interesting. As this reaction proceeds, there's some carbon dioxide building up in this. And you can actually take a spent light stick, and if you're really careful, you can poke a hole in the headspace, and you'll hear a little hiss as the carbon dioxide gets released. Don't believe me? Try it for yourself. That's the nice thing about science. You don't have to believe anyone. You just try as long as you try the experiments for yourself, right? And you're honest about the results that you get. Anyway, when this carbon dioxide dimer reacts with the dye, thank you there, Karma, it's going to form this CO2, and what happens is some energy gets transferred to the dye. The way we signify this is we put a little asterisk on the dye. And then that dye gets rid of that extra energy as light. And what's cool is different dyes give you different colors of light. That's it. It's no simpler than that. So let's get some of this glowing white light stick fluid. The way I do that is I take some PVC cutters. I'm going to cut this right off at the top here. Right like that. All right. That goes in there. That's my waste container. I got to clean off my PVC cutters. All right. You can see the glowing fluid on there. Let me get that off. Theories are trash. Somebody doesn't understand what a theory is. Okay, here we go. Let's go ahead and put a little bit of the white light stick mixture in here. There we go. No, this is not fission. This is just a chemical reaction. Fission is a nuclear reaction. Fission is a nuclear reaction. All right, let's pop this in here. So here we go. This goes here, this goes here. All right. Let's put a little bit of white light stick fluid in here. A little bit of white light stick fluid in here. Back here will be our control. That's my control. You can see what happened to the napkin when I wiped a little bit of the glowing light stick fluid on it. All right. Okay. All right. Now what we're going to do, thank you there, Junaid. Appreciate that. Thank you there, X Gaming. I appreciate that. Sorry, I just had to take some time, and someone was spamming the comments. I got rid of them. So, okay. All right, now what I'm going to do is I'm going to add a little bit of red fluid, red dye, to our glowing light stick mixture over here. So notice I've added a different dye, and just like different markers have different dyes that give you different colors, different dyes and different light sticks give you different colors. To kick this off, I'm going to add just a drop of base so we can see the color shift. There we go. That's going to kick off the reaction. And sure enough, we are noticing a change in color of the glow of the light stick components. It's like a pink, fiery orange. Oh, the BZ reaction. I'm loving some of that, Dr. Yu. Loving that stuff. Dye 1 green. We can give that a shot. Now, this might sound funny. Is it possible to buy that TCPO? What you can do, is, just get a glow stick, man. Just get a glow stick and cut it open prior to snapping it. And then it's going to be the stuff on the inside of the, is that right? Yeah, it's going to be the stuff on the inside of the vial. Now, it'll be mixed with dye, but yeah, you'll have some TCPO dissolved in there. Can you have infinite glow fluid? Not really. Just like we don't have an infinite supply of fossil fuels, we're not going to have an infinite supply of TCPO. Is it producing energy? We got to be careful there, Big Gaming. We're going to say the reaction releases energy. So forgive me if I'm being condescending there. I don't mean to be. I'm just trying to be really specific about about words there. And it's hard to do over a YouTube live like this. Why, after adding base, it gives it specific color? So, Priyanka, what's going on there after I add base? So, there's a couple things that are happening here. The different color gives you, the different dye gives you a different color. Now, it's also the case that base is going to catalyze the reaction. So, it speeds it up, and that's why it's a little bit brighter right now. The other thing is adding the base to this makes it so that the dye can dissolve into the fluid. And if the dye doesn't dissolve into the fluid, you're not going to get the glow. It actually has to dissolve. So, Lord Stormia, I think you probably could. Not giant bottles, but, you might be able to, look up, say, for example, so let's talk about this hot gas. This is how a theory works. This is exactly how a theory works. So folks are wondering about theories, so let's talk about that, all right? What a theory is a set of assumptions. That's right. A theory is a set of assumptions. And you might say, well, geez, if it's a set of assumptions, it's crap right to begin with. Well, not exactly. So I got you your green color there. So how can a set of assumptions be any good? Well, let's think about this. Look at that glow. Isn't that gorgeous? Absolutely gorgeous. That's a yellow-green glow for you there, I think. We're going to call it that. I don't know. I mean, you might disagree. That's fine. But I can see a little bit of a green there. It's mostly yellow, however. So anyway, how can a set of assumptions be any good to us? Well, it works like this. In science, now make sure you listen to this whole thing here. Don't go taking one part or the other. You got to take the thing in total. In science, you can assume whatever you want. But here's the kicker. And don't quote me on that first part without including the second. So here's the first part. In science, you can assume whatever you want, but what you assume has to conform to what you observe. That's what makes it science. And what makes a good theory is your assumptions match what you observe in as many cases as possible. And so that's how we rank theories. If someone has a set of assumptions that it explains a wide variety of observations, then we say that this is a good theory. And you can rank theories. Some theories are crap. Some theories are good. No theories are perfect. But some of them are, wow, are they good? Like the theory of evolution or quantum theory or gravitational theory. There are some theories where we know a lot about things. So here we go. How are theories and hypotheses different? That's a great question. And, I don't think about hypotheses a whole lot. A hypothesis is like what I did today. I said, I think if I use broccoli, I can get the chlorophyll. I've never tried broccoli before, but I can get the chlorophyll out of broccoli and make it glow a pink color. And then you can test it. You can just test it and see if it works. A really good hypothesis becomes a theory once it starts to form an organizing principle of thought. Thank you there, Spiral. I appreciate that. So what I mean by that is you can have a hypothesis like, I think this will happen. That's an assumption. But if you start making guesses, assumptions that start to explain more and more and more things and match more and more and more observations, then your hypothesis gets ramped up to the level of theory. I don't know. You may all think I'm crap. That's fine. I've been teaching science for a long time, and, there's not one perfect definition of science. I'm just telling you the way I think about it, having studied science and the philosophy of science and things of that nature. I'm no philosopher of science. However, I've read quite a bit about it. There you go. Let's try something else. I'm going to try another dye that I've not tried before. I have no idea if this one's going to work or not. Oh, let's get a couple here. I don't know. I got a blue dye over there and I got a green dye over there. That's what we're going to try. All right. Here's that one. And here's another cup. All right. We're going to try these. This might be the end. Hey, thank you there, Oreo. I appreciate that. So someone's got a question, a doubt. When you add base, you already know it's a catalyst, but we looking at how we get to know what is doing in the reaction. I apologize, Priyanka. I really am sorry. I don't understand the question. So Lord Stormia says they know something that is impossible. A glow fluid glowing black. I love it, man. Well done. Well played there, Lord. All right, let's get these in there. Let's see if we can change these colors. I don't know if these are going to work. I've never tried these before, okay? So I'm going to try this blue dye over here. We're going to try a red dye. Hello there, AJ. Let's see what happens, baby. Come on, put the drop in there. There's our blue drop. So I'm going to put the blue back here so we got an eye on that. We're going to put the green drop over here. If these don't work, they don't work. Who knows? There's a couple drops of green. All right, let's give them a swirl each. There's the green. That's got like a blue shift to it, just a little bit. And since I'm not sure that the dye has dissolved, I'm going to go ahead and add a drop of base there. Oh, I think we may have gotten... Here we go, baby. Look at that glowing green, huh? Actually, it's blue. I'm going to call that blue fluorescence. You can see that the shift has gone from the white light stick color to a more blue one. So for whatever reason, this green dye is fluorescing blue. The other material that you see is just undissolved green dye. Thank you there, AJ. Now we're going to try this one over here, which remember, this is just a blue dye. I can tell it's having a hard time dissolving, so we're going to add a little bit of base. That'll help the dye dissolve. And it'll also, in addition, speed up the chemical reaction. Sure enough, it looks like that blue dye is a blue fluorescer. Look at that. Really pretty. Really gorgeous. Both there, Uniyid or Juniyid. Yeah, hot gas. I mean, here's the deal. We're going to talk philosophy here. So hot gas says, hey, so it's a hypothesis, then a theory, and then a theory, and then a fact. So if you think about it, in science, there are no facts. So why do I say that? I mean, so a fact is something that is known, right? And okay, this is philosophical here. Of course, there are scientific facts. There's things that we quote unquote know. But another way of thinking about it is, in science, you always are open to the idea that you're wrong. And this is what makes science so very, or I should say scientific thinking, so very different than anything else. In scientific thinking, you're not trying to prove anything. You're just trying to see what is. This is when scientists are doing their best. They're not trying to prove stuff. They're just trying to show what is. That doesn't mean they're not trying to gain evidence. I mean, I try to gain evidence to see what's happening all the time. And then I use that evidence. To try to explain what I think is happening. But in science, we are always open to the idea that our ideas can be better. We don't take anyone as the authority on anything. The authority happens to be nature. The authority happens to be observation. That's what we use as our authority. We don't use a textbook. We don't use religious texts. We don't use religious teachers. That doesn't mean that we don't look to people who have a lot of experience, who understand things better than us. I do that all the time. I'm always asking people to help me figure things out, all the time. But I'm always trying to keep an open mind about how I could be wrong. So what you're doing is you're being open and skeptical at the same time. I thank you, Priyanka. So the question is, how does the base act as a catalyst? That's a great question. I'm not sure I'm going to be able to answer that, Priyanka. I would have to go back and look at some of these articles that deal with this. But a base is going to probably, oh boy. I'm not an organic chemist. What would a base do? So that's going to be a proton acceptor. So a base is probably going to act on this to begin with. I don't see anywhere here it's going to... Anyway, it's going to interact with some of these. So a base, let's just say, for example, could take a proton from this, and that would make this even more reactive than it was before, and then it could attack this and cause the cascading events that splits this into 3 pieces. So I apologize. I don't have the specifics on that. H2O and bleach to a sample? That's just going to dilute the bleach, right? So anyway, so it's possible that people 100 odd years from now will look back at our time and think we were stupid for not understanding. I mean, that's one way of looking at it. But for example, I don't think Aristotle was stupid. I don't think Newton was stupid because he didn't understand Einstein's theories. The people at the time, I mean, Newton was brilliant. Newton wasn't stupid, but he was wrong. So that's sort of the way I look at it, right? I mean, people are using the knowledge and the observations they have to try to explain the world around them as best as they can. All right. Sorry, Priyanka. I apologize. I would have to... I don't have that information easily accessible in my head. I would have to go read the articles that describe how they think these reactions occur in order to answer you. So I apologize, Priyanka. I can't answer your question. However, perhaps there's an organic chemist here in the chat that can give us some insight into how bases catalyze the glow stick reaction. And if you Google it, or talk to AI, it'll probably do pretty well for you. All right, here we go. Yeah, of course, hot gas. Like, think about it. You do that to yourself. Right? As you find out more, you figure out stuff you were wrong about before. Hopefully we all go through life doing that, right? I mean, that's just good thinking, man. All right, so we know that bases catalyze this reaction. I happen to know that this stuff is a base, this stuff here. So I'm going to just add a little bit here and see if it works. So instead of adding fluid, I'll add a little bit of solid. Give it a shot, see what's going on here. I don't know. Put in some of this. Oh, yeah, look at that. Totally. Look at that. Look at how, woohoo! Look at that baby glow, huh? Man, that's kicking off. You know what? Here, let's just pour it in here real quick. See what happens. See if we get this glowing pink. Boom! I don't think so. Nope, I don't think we got it going. What the heck? We'll pour it back in this way. Maybe we'll run it. That's so pretty. Just a little bit. See if we can get some pink fluorescence. There it is. You can totally see just a little bit, right? Come on, man. You see that pink fluorescence? Totally. That's chlorophyll fluorescence. It's not really, look at that. That's really nice. It's not highly vibrant. You know what, you all? Okay, this is really cool. I'm going to tell you why this is really cool. Because to my eyes, the pink here is less bright than when I look through my phone. And I'm thinking that's because that this is giving off some infrared light. And, you know, your phone can pick up infrared light that your eyes cannot. Look at my latest short that I posted, and you'll get an idea of what I'm talking about, of why I think this might be infrared light. I'm not sure it is. I'm just, you know, there's some experiments I can do to figure it out, but I don't have that with me now. Thanks there, AJ. That'd be cool there. I agree, Lord Stormy. It'd be nice to have a bottle of it. All right, I'm going to flip this camera around. If you don't want to see me, now's the time to get out of here. You're not going to hurt my feelings. I'm an old man in my basement, so do not sweat it if you got to get out of here and you don't want to see this. All right, let me just clean up a bit before I do that. And then we'll talk to you, and then I'll call it quits for the day. By the way, in case you're interested, I now sell some merch, I guess, on my channel. I got my let's see if I can get this so you can see it pretty well. There we go. Here's my shirt that I'm wearing. So many experiments, so little time. You like this kind of thing? I happen to put it on a tie-dye design, but you can use whatever color t-shirt you want. If you feel like supporting the channel, you know, head on over to my merch store. You can just go to my main Tommy Technetium page, and there's a little link right there you can follow. Thanks there, AJ. Hello, Bentley. I don't know AYY. I don't know how to do that. I'm not a synthetic chemist. I'm the wrong guy to ask. Priyanka, yeah, I mean, I'm a 57-year-old guy. I've been teaching science and chemistry for over 30 years. I love doing science experiments for people. I'm intensely curious about all sorts of crap. How about you, Priyanka? Tell me a little bit about yourself. Everybody, why don't you everybody drop in the chat a fact about themselves? What if you add the glowing stuff in the bottle behind you? I'm not sure, Dylan, what you're asking. I apologize. What bottle behind me? So we got someone here doing a master's in science and zoology. Very cool, Priyanka. So you are probably into bioluminescence. Bioluminescence is some of the coolest thing. Now, the house I used to live in, there'd be some fungi that I'd see on the ground late at night that would glow. It was really fun to see. Priyanka's from India. Very nice. Steven, looks like they do some freelancing. That's cool. What kind of freelancing there, Stefan? Let me show you a few more. I guess, designs from my channel. This one's you don't need to know a lot. Just stay curious there, Spiral. Just stay curious and keep learning. This is kind of my philosophy of science. It's part of it. Oh, it looks terrible. I hate this. Here, let's do it this way. Let me turn this around so we can see this right. I've never had a failed experiment. Only new observations. That's what's nice about science. If you're doing science the right way, you're not trying to get a result. You're not trying to prove something. You're just trying to see what is. And so when you set up an experiment, it doesn't go the way that you expected, that's okay, man. Nature's trying to tell you something. Figure out what nature's trying to tell you. And with that type of attitude, you never fail in the lab. You just pay attention, see what's going on. And if you want something different to happen, then you think about you know, what's happening in the experiment and change the parameters as you see fit. Yeah. Anyway, let me turn this around. Yeah, and then here's the one that's on this tie-dye shirt that I got here. Let me turn it around real quick. Then we get back to chatting. So many experiments, so little time. That's my life right there, man. You guys have no idea how many experiments that I want to be doing. I just don't have the time to do it all. So many experiments that I want to do. Hello, Priyanka. Hello, everybody. You know what? I think it's time for me to call it a day. What in the world is that? A little bug or something. What's this? Science is amazing, and I enjoy simple stuff like the glow sticks. Thanks there, Hot Gas. As well as the crazy stuff on YouTube with these channels. I agree, Hot Gas. Very cool. Well, hey, thanks for joining me today. Remember this. Here's another design. I totally, did I put it out here? Maybe I didn't. I guess I didn't. But no, just remember that, you know, the beauty is the universe is always around you. I mean, it's all over the place. Whether you're dealing with glow sticks, walking by a river with all the nature that's around, or seeing the beautiful clouds, orange, purple at a sunset, whatever it happens to be. And what's cool about science is it allows you to appreciate all the beauty and wonder of the universe at a deeper level. So not only do you get to feel the awe of seeing the Grand Canyon or a huge mountain or whatever it happens to be, or the Pleiades or the moon, you feel the awe of just how remarkable it is that this universe exists. At the same time, if you know your science, you can understand some of the workings of how these things do exist, how they behave, how they operate, and that just adds to the beauty and the awe that you get to see. I like to say, you know, the universe is having a party, and science gets you on the guest list. So, hey, thanks there, AJ. If you like these kinds of things, you know, my channel might be for you. If not, that's okay. Thanks for hanging out with me today, and I'll probably see you next time around, probably next weekend. Thanks, everybody. Love having you on board. See you next time.